Welcome to my video. In this video I'll explain what computational thinking is for AQA's GCSE in computer science under the topic of representing algorithms. I'm going to start off with what computational thinking isn't. So, computational thinking is not thinking like a robot. It's not thinking like a computer. It's not thinking like a machine. That is a common mistake that a lot of people make when looking at the word computational and thinking. So, what is computational thinking and why is it so important? It's actually a very, very powerful tool to master. Okay? It's a skill that focuses on logical and critical thinking. It's basically a problem-solving skill, an approach that you would take to solve the problem or a task. So, computational thinking is about looking at a problem and breaking it down logically and systematically. If this is done correctly, it should result in your algorithm and then your implementation of the algorithm, which becomes your program, being efficient and effective. Computational thinking allows us to take a complex problem, understand what the problem is, and develop a solution. We are able to do this in such a way that the computer, the human, or both are able to understand it. Now, computational thinking has four main steps that you need to be aware of, and these are listed on the left-hand side of my screen. They are decomposition, pattern recognition, abstraction. I'm going to try and say this last one, I really struggle with it, and algorithmic thinking. There we go, I managed it. I always struggle with that. Okay, so I'm going to talk you through the reason why computational thinking is so important. So here I've started off with, I've got some parcels and I have got a factory that I've got. There's a picture at the bottom. I want you to imagine that this is a brand new factory that's opening and they've had all of their stock delivered, and the stock has literally just been dumped in a big pile in the middle of the warehouse, and they want it placing alphabetically on their shelves. Now obviously in a real factory there'll be thousands and thousands and thousands of shelves, so that's going to be quite a labour intensive job. So ideally, if you think from a computational point of view, you want that to be taken under a logical approach, a systematic approach, resulting in you being efficient with your time and efficient with how you do it. Now for this example I'm going to completely ignore all of those. I am not going to apply any logic, I am not going to follow a systematic approach, and I'm definitely going to not be efficient. So let's take a look at why computational thinking should happen. So this is basically a really bad example, okay, of how computational thinking should not be done. So here we've got some parcels, okay. I'm going to place all of these on just one shelf just for this example. So the first item I've got is in fact a monitor, okay, and looking at my shelf there's nothing on there at the moment. So alphabetically, okay, I am just going to grab monitor, it's the first one I've grabbed, and I'm going to stick it on the shelf. So now that's already there. So I've picked that up and I've physically handled it. I have taken time and effort to put that there. Okay. The next item is some RAM. Now I've already got a monitor on my shelf, so I'm just going to put the RAM next to it because there's a gap. Okay. Notice that I haven't put it in alphabetical order already. So I'm going to grab a book. Okay. And there's two things already on the shelf, so I'm just going to place the book on the shelf, and then I'm going to grab an abacus, and there's three things on the shelf, so I'm just going to place that on the shelf. And straight away you're looking at that, and just like myself you're thinking, well, it's not in alphabetical order, and you are correct. So bear in mind I've already picked each item up once and I've already placed it on the shelf once. So what I'm going to do now is start moving them around. Again, that seems quite labour intensive and it seems like a waste of time. It's extra steps, it's very inefficient. So I'll move the monitor out of the way and I look for the item. So now I'm walking all the way around the factory, okay, obviously on a larger scale, and I'm looking for the item that's got the first letter in the alphabet. So A is the only one here, so I would move the abacus to there. So I've had to pick the abacus up and move it again to a new location. I'm then going to pick the monitor up again, I'm going to move it, and I'm just going to drop it on the end of the shelf. Okay, I'm then going to move the RAM out of the way. Okay, notice I've had to move the RAM again for a second time. Okay, I'm then going to move the book over for a second time, and then I'm going to move the RAM again and place it on the shelf. I'm then going to move the monitor again, and I'm going to move the RAM again, and then I'm going to move the monitor to where the RAM was. And you'll see that that was really inefficient. It wasn't logical, it wasn't systematic, and actually it took a long time, and it was a waste of the person who would be doing that's time. So computational thinking, let's think about that now. So this method was inefficient and it wasn't a logical approach at all. So here they are, they're currently unordered. So I've got all of the items. So this time I've bothered to look at, okay, the items, and this time I'm applying computational thinking. So I've looked at them, and the first thing I would do is I would create an algorithm, okay, that would order all of the items so I knew the alphabetical order of my items, like so. So now they're already in alphabetical order. So I know the first item is abacus, the second item is book, the third item is monitor, and the fourth item is RAM. So now let's look at how many times that I now have to place them onto the shelf. So the abacus, it goes down, the book, it goes down, the monitor, it goes down, and the RAM goes down. It's efficient and it's logical. So therefore, I've actually managed to save time by thinking about it logically and grabbing the item that was first alphabetically in the first place and placing it on. So I only handled each item once then, so therefore that's why it's more logical. So again, let's recap. Computational thinking solves problems by applying logical and systematic thinking, resulting in the algorithm or the end program being efficient. Okay, it's also effective because it's less resource intensive because it's not using more resources because of it being efficient, and also it would take far less time because you're getting it right in the first place rather than having to keep changing things. So that's a really important factor for computational thinking. That's pretty much it. I hope you enjoyed that video and I hope it helped you revise. Thank you for watching. Any questions, please feel free to contact me on this channel.